Good morning, Gabby. Give another minute for people to show up. The conjugate's pretty easy. This shouldn't take long. Then you can finish your work from yesterday or ask questions or do some science or whatever you got left to do. I'm going to go ahead and get started. This isn't hard. It'll take a couple minutes to do the ones that you got left probably from yesterday if you didn't already figure it out. But today's about conjugates. Conjugates are pretty simple. Conjugates are the sum and difference of the same two terms. So this is one term, this is another term. You'll note that they are the same term. The only difference is that this one here is being added and this one's being subtracted. So it's a sum of it and a difference of it. We use these a lot with the radicals because when you multiply your conjugates together, you get perfect square. Well, you get pretty much perfect squares. So it's going to help rationalize your denominator of things. So when you have things like this and your denominator has addition and subtraction in it, what can you do to get rid of the radicals in there? Because we don't like radicals in your denominator. So anyways, we can multiply the two conjugates together. So here we can do it by foiling, and if you remember from yesterday, you can just FOIL these together. It's going to be really simple though. You got the square root of 5 times 5, which is 5. You got the square root of 5 times, oh, I'm sorry, one of these is going to be minus. You got the square root of 5 times the square root of negative 2, which would be negative 2 times the square root of 5. Then you got positive 2 times the square root of 5, which is going to cancel that out, which would be the positive square root of 2 times the square root of 5, right? So these two things are going to cancel because this one's going to be negative and this one's going to be positive. So they'll cancel. And then you get negative 2 square roots. I guess we have, technically you have the minus sign there. and we'll do it that way. And then you'll have square root of 2 times the square root of 2, which is just 2. I'm sorry, that's a negative 2, which is just negative 2. Right? And then your middle terms here are going to cancel. They are the inverses of each other. So every time you do it, you're picking this specifically so these middle terms cancel. So this is all going to go away. That's all 0. And you just get 5 minus 2, which equals 3. So the product of these two conjugates is 3. This equals 3 when you do it all out. So it's really simple. You're just kind of foiling, but your middle terms here are always going to cancel because that's what you're choosing to do it with. So why is this important? It's important for problems like this when we want to simplify it and rationalize your denominator here. If you remember from like 3rd grade when you learned about equivalent fractions, right, you can multiply your denominator and numerator by the same number and not change the value of that fraction. It's called the fundamental law of fractions. You do it for when you simplify fractions or when you find equivalent fractions. I mean, you've been doing it for years now. The question here is, what number do we want to multiply the top and bottom by? Well, you want to multiply it by this guy's conjugate. So what we're going to do is you're going to multiply your denominator, this whole term, by its conjugate, right? The square root of 5 plus the square root of 2. Of course, if you do it to the bottom, you're going to have to do it to the top as well. So we're going to multiply this by the square root of 5 plus the square root of 2. And in doing so, your denominator is going to rationalize. You're going to get the radicals out of there. We just did this one over here. So when you multiply this out and FOIL it out, I guess I'll write it again. Right, you get 5 times the square root of 5 times the square root of 5, which is 5, plus the square root of 5 times the square root of 2, which is the square root of 5 times square root of 2. And then you have the negative version of it, right? Negative square root of 2 times negative 5 minus the square root of 5 times the square root of 2. So these will cancel. Right, so this is all going to cancel. And then you have the square root of 2 times the negative square root of 2 times the square root of 2, which is 2. So then this all cancels, and you're left with 5. It's negative 2, sorry. This is a negative, so this is a negative. So you get 5 minus 2, which is 3. So here your denominator is going to become 3. Then your numerator, you need to simplify. So here you're going to distribute it, so you're going to get 6 square roots of 5 plus 6 square roots of 2. You're going to look at those, see if you can actually simplify any of them, and it does not look like you can. It might be nicer to leave it as such. I'm going to look to see how the book does it, because you have the option. You probably could just leave it as 6 times the square root of 5 plus the square root of 2, or you could actually distribute that out. I'm going to see what the book actually tells me what we should do here. If the book actually tells me this one. Okay, yeah. So you want to do it like that, because then we can actually deal with the whole numbers here. We can actually simplify the whole number. We can do 6 divided by 3, and that's why you want to do it this way. So we're not going to go to this step, because we're just going to have to redo it anyways, but we'll do 6 divided by 3 here. You can take out the 6 and the 3, they are divisible. 6 divided by 3 is 2, and then that would be times the square root of 5 plus the square root of 2. I think that's how it ends it. No, then it actually distributes it out. So 2 square roots of 5 plus 2 square roots of 2. I'm not going to be picky on how simplified you get, because this, to me, this here is just as great as this, but if it wants you to take out the distributive property, go for it. Let's do another example there, especially because some people might be showing up a little late here. So let's get rid of this side, and we'll get rid of this. We'll keep our words so we actually know what's going on. Let me see if I can find another example. Let's see, let's do 4 over square root root of 7 plus the square root of 5. So again, you want to multiply your top and bottom by the conjugate. And again, that's just going to be the other version of this one. So we're going to multiply our denominator by the square root of 7 minus the square root of 5, right? Conjugate. You do it to the bottom, you got to do it to the top. Square root of 7 minus the square root of 5. This here, again, you're going to do all your foiling and stuff, but I mean, you should be realizing it's just going to be 7 minus 5, which equals 2. So your denominator here is going to be 2. You could do it the long way if you wanted. Square root of 7 times square root of 7 is 7. Square root of 7 times the negative square root of 5 will be canceled out by the positive square root of 5 times the positive square root of 7. And then square root of 5 times the square root of 5 gives you negative 5, because that's a negative. So 7 minus 5 gives you the 2. Then up top, you can divide by the 4. So this will be square root of 7 minus the square root of 5. Again, you can simplify the 4 halves to just be 2 times the square root of 7 minus the square root of 5, and then you can distribute 2 square roots of 7 minus 2 square roots of 5. And there's your final answer. Let's do one more, and then I'll see if you have questions from yesterday's homework, and then we'll be done for today. Again, conjugate's not too difficult. Takes some getting used to, but not too bad. Let's do negative 3 over, I'm sorry, that's a negative 4. Negative 4 over the square root of 10 plus the square root of 8. So here we got a negative in the numerator. It's not really the only difference here, but you solve it kind of the same way. Multiply this one by the square root of 10 minus the square root of 8, and multiply this one by the square root of 10 minus the square root of 8. So again, it is the conjugate. You're looking at the sign here and you're using the opposite one, because that way when you FOIL this, you're going to get your perfect square, and that's going to be 10 minus 8. And 10 minus 8 is going to give you 2 as well, so your denominator will be 2. Up top you have negative 4 square roots of 10 minus square roots of 8. Don't need that anymore. Here you can divide out the negative 4 and the 2, and becomes negative 2 times the square root of 10 minus the square root of 8, and then you can distribute your 2. Negative 2 square roots of 10, and watch your sign here, this is a negative, so a negative times a negative is a positive. Positive 2 square roots of 8. And you're good. Any questions? Anybody want me to do another example of things? Or anybody want me to check to see if they were doing their homework right yesterday? You should have been able to get through most of it with the exception of like 28 through 33, because those are the ones you need the conjugate for. But everything else you probably should have been able to do from yesterday's lesson. So right now, if you have any questions, that's what I will answer. If not, finish up yesterday's work and get that into me. I'll hang around for another minute here, see if anything pops up. You can always email. Next week is probably going to be pretty easy. So we're getting kind of down to the end here. I honestly don't know how much further we're going to go. If you come up with questions later, you can always email me. But no one seems to be talking right now, so. Well, if we don't have any questions, then I'm going to end it. I will talk with you next week. Be working on your science. If you have any questions on science, like you figure out what the Rube Goldberg machine is, that should be a fun assignment for you. And your parents probably. You'll make a mess. So if you have questions about any of it, please let me know. You are coming down to the end here. You have till the 28th to get everything in. Your graduation is coming up. I think there's some plans in the work for that. Might be something similar to May crowning, probably a little different. I've never done graduation with you guys, so I don't know what you all are used to. So if there's no questions, I'm going to end it. Send me an email if you get questions later on. I will try to get back to you, and have a good weekend. I will talk to you.